Let's suppose that we have a grouped frequency distribution as laid out here that has boundaries from 19.5 to 24.5, 24.5 to 29.5, so obviously width of 5, on down to 44.5 to 49.5, so that's 1, 2, 3, 4, 5, 6 classes. And the frequencies of this classes are 5, 8, 10, 7, 6, and 4. And finding the cumulative frequencies just means we're going to add how many data values do we pick up as we travel from the lowest boundary of the first class to the highest boundary of the last class? And we see then that in the first class we pick up 5 data values. In the second class we pick up 8 more for a total of 13. Then we pick up 10 more for a total of 23. So by the time we get to 34.5, whatever data values are less than that, we will have a total of 23 data values. And then as we go on up to whatever data values are less than 39.5, we have a total of 30. 23 plus 7 is 30, plus 6 is 36, plus 4 is 40. And since the cumulative frequency of the last class is 40, we have 40 total data values in the data set. Now this next column gives us the relative cumulative frequencies, which just means relative to the entire data set, how many data values will we have accumulated by the time we get up to each respective upper boundary? So, in the first class, we have a cumulative frequency of 5. If we divide that by 40, we wind up with 0.125. In the next class, we have a cumulative frequency of 13. If we divide that by 40, we wind up with 0.325. So the proportion of data values that we will have accumulated by the time we get up to any data values that are less than 29.5 would be 0.325. And we can keep going down here. The cumulative relative frequency of the fourth class is 0.75. The cumulative relative frequency of the fifth class is 0.9. And then, of course, the relative frequency of the last class is 40. There are 40 data values, and we expect that number to be 1. 100% of the data, in other words, by the time we get to the upper limit of the last class. Now, we'll notice that this value here is 13. This column represents the cumulative percent. Now we have 0.125 here, but what we're going to do is make a percentile graph. And this word percentile, implying percent, meaning 100 for every 100, implies then 100 positions. In the same way that the quartile implies breaking a data set up into 4 pieces, 4 equal pieces, a percentile implies breaking a data set up into 100 equal pieces. So it wouldn't make sense for us to have a 12.5 percentile or a 32.5 percentile, because that would imply more than 100 pieces. So we can see that these cumulative percents are rounded. So for 12.5, we've rounded to 13%, 32.5, we've rounded to 33%, 57.5, we've rounded to 58%, and on down. And of course, again, 100% of the data by the time we get to the upper boundary of the last class.